In this question, a scientist is carrying out a reaction and measures that the initial rate of formation of ammonia, NH3, is 0.698 atmospheres per second. Our goal is going to be figuring out the initial rate of change and type of rate for the other substances in our reaction. So our first step is going to be balancing the equation. So I'm going to make a little table with my hydrogen and nitrogen for my reactants and products. So looking at my reactants, I've got H2, so 2 hydrogens, N2, so 2 nitrogens, and NH3, which gives me 1 nitrogen and 3 hydrogens. So neither my nitrogen or my hydrogen are balanced to start with. I'm going to try adding a 2 in front of the NH3 in the products to try and balance out my nitrogens and see if that balances my equation. So if I recalculate how many of each I have, we've still got H2, so 2 H's in the reactants. We've still got N2, so 2 N's in the reactants. Now in the products, we have 2 sets of NH3. So that's going to be 2 N's and 2 sets of 3 H's, which will be 2 times 3, which is 6 H's. So now it looks like my nitrogen is balanced, but my hydrogen isn't. I've got 6 in the products, but only 2 in the reactants. So I'm going to make a guess that adding a 3 in front of my hydrogen in the reactants might fix it. And I'm going to recalculate and see if that worked. So I've now got 3 sets of H2, so 3 times 2, which is 6 hydrogens in the reactants. I've got 1 set of N2, so 2 nitrogens in the reactants. In the products, I've got 2 sets of NH3, so 2 N's and 2 sets of 3 hydrogens. 2 times 3 is 6. Awesome. So my hydrogen and nitrogen are both balanced. I can go ahead and enter those numbers. Remember, on this website, you do need to enter a 1 if you've just got 1 of something, even though if you were just writing out that equation, you wouldn't need a 1. Okay, now to figure out the initial rate of change and type of rate for each substance. Let's start by filling out our known value from the question, which was the initial rate of formation of ammonia is 0.698 atmospheres per second. So we can fill that in here, 0.698, and that's a rate of formation. That makes sense because ammonia is in the products, it's being made. So that's what's being formed. Because that's being formed, we know any of the reactants are getting used up or consumed. So for hydrogen and nitrogen, those are going to be rates of consumption. So we can fill those out here. Okay, all we need to do now is figure out what will the rate of change be for our hydrogen and our nitrogen. And we're using stoichiometry to do that because looking at our reaction here, looking at our balanced chemical equation, if I want to make 2 moles of ammonia, I need 1 mole of nitrogen. So it's not going to be the same rate. It's going to be in ratio with how much we have in our balanced chemical equation. So I'm going to set this up like a normal stoichiometry problem with a dimensional analysis table. So I'm going to start by writing the initial rate of change of my known thing. So I've got 0.698 atmospheres per second of ammonia. And if I look in my balanced chemical equation, if I want to look at hydrogen, for every 3 moles of hydrogen that are used up, I get 2 moles of ammonia made. So that's going to be my ratio I'm using in my conversion table down here. So I want to get rid of ammonia and I want to end up with hydrogen. So that's why I've got hydrogen on the top and ammonia on the bottom, so it'll cancel out. Then I'm putting in my numbers. For every 3 hydrogen that get used up, we make 2 ammonia. So now everything on the top multiplies. We can cancel the ammonia out. So we end up with 0.698 multiplied by 3 divided by 2 atmospheres per second of H2 hydrogen. So if we put that into our calculator, that's going to get us 1.05 atmospheres per second of hydrogen. So you can see we've basically just used that ratio. If we need 3 hydrogens to make 2 ammonias, then we need a rate of 1.05 atmospheres per second of hydrogen in order to make ammonia at a rate of 0.698 atmospheres per second. Let's fill that in to check we got it right. Awesome. Okay, so last step, we're doing exactly the same thing, but this time for nitrogen. So I'm going to set up the same way. This time, looking at my balanced equation, I'm looking at nitrogen and ammonia. So for every 1 mole of nitrogen, we create 2 moles of ammonia. So I'm going to again put ammonia on the bottom here. I'm going to put nitrogen on the top, and then I'm going to put in those numbers to balance it. So 1 mole of nitrogen gives 2 moles of ammonia. So now the ammonia is going to cancel. We're going to multiply everything on the top, divide by everything on the bottom. So that gets us 0.698 multiplied by 1 divided by 2 atmospheres per second of nitrogen. So putting that into our calculator, we're going to get 0.349 atmospheres per second of nitrogen. So again, let's go ahead and fill that in to check we got that right. Awesome. So just as a kind of sanity check of this problem, we know the ratio between nitrogen and hydrogen should be 1 to 3. So looking at our numbers here, we should see this multiplied by 3. And 0.35 multiplied by 3 gets us 1.05. So that makes sense. We need 3 times as much hydrogen, so a 3 times higher rate for hydrogen than we do for nitrogen. We can also look from nitrogen to ammonia. For every 1 mole of nitrogen used up, 2 moles of ammonia get made. So that means the rate for ammonia should be 2 times that of nitrogen. And that makes sense because if we look here, we've got about 0.35 atmospheres per second for nitrogen, and we've got about 0.7 for ammonia, which is double. So that also makes sense.